Afternoon. Welcome to the Critical Canadian Home Building Science Part 8, Intentional Design for Occupant Covered Homes. We're always so pleased to be working with Enbridge. I'm Gord Cooke with Building Knowledge Canada. We'll just hang on for a few minutes, let other people join, but I'll give you a sense of who's in the call. Stacy, you're always kind enough to help us from Building Knowledge with the logistics, and you'll be running the polls. And if folks have any issues connecting and so on, they can converse with you a little bit. Is that okay?
Yep, we're good.
We also have Emma from our staff just kind of supporting things a little bit. You're seeing Angela there on the screen, and then we had this wonderful guest pop up, Robert Bean, who I'll introduce in a bit. But Robert, thanks for joining us.
Yeah, not a problem.
Where are you today?
I'm actually in Calgary. I was on my way up to Edmonton. I had a date with a paint sprayer, Gord. We were doing a renovation up there, and it was painting time. But given the choice between dating a paint sprayer and dating you guys, this was a much better date.
Oh, that's way too kind of you. And as I say, I'll introduce Robert in a minute. So we'll just give people a few minutes, and Stacy, you'll give me a sense of how many we got and when you think we should start.
Well, as you know, Gord, lots of people aim to get on at the time that our webinars start, but that's not always the case. But we have like close to 200 people signed up today. We probably won't get them all hopping on the call just yet, but whenever you're ready, let me know.
Oh, you think we should start then?
Well, this has been my experience that they will trickle in the next 3 minutes. And I just know the way your conversations are going to go today, that lots of people will have questions for you.
I'm just having a little trouble finding how to get rid of my Q&A on my screen. There it is. Why won't that get rid of? Go escape. There it is. Okay. I'm going to wait one more minute.
We were talking earlier about the word dweeb as a Canadian icon word next to toque.
There you go. That is interesting thought.
That was Gord's word, by the way, dweeb. I haven't heard that word in probably 60 years, 55 years.
Still trying to figure out a way to get things showing here.
There you go.
I'm going to stop sharing just for a second. So I can see folks a little bit.
Still see.
Yeah, that's fine. There we go. Good. I just want to be able to see folks a bit. All right. So I said one more minute, and there we are at 1 more minute. So again, good afternoon for those who've just joined us. My name is Gord Cooke, Building Knowledge Canada. We're always so pleased to work in partnership with Enbridge to offer up these, well, I guess it's monthly, home building science sessions. This happens to be part 8, which means we're getting near to the end of the year. This particular one is Intentional Design for Occupant Comfort in Homes. I'm joined by Angela Bustamante from our office. Those of you who haven't met Angela would be interested to know that she is our Director of Technical Services and is responsible essentially for helping builders make better choices with respect to energy programs. But Angela, today we're going to chat about how those same choice for energy efficiency also help with comfort. So just say hello, Angela, and give people a sense of what you do.
Hello, he said. I'm Angela. I definitely work with builders daily from the planning to department to site, and comfort plays a role in every thought and process that we go through. And hopefully we'll be able to touch on some of those main key areas that should have some builders thinking.
Thank you. And then I said earlier, for those who weren't on the call, we were chatting with Robert. I saw him a couple of weeks ago in Saskatoon at the Canadian Institute of Plumbing and Heating Conference. And Angela said, we're doing comfort. Shouldn't we have like the comfort guru, the comfort doctor on this, the Pope of comfort? You know, I mean, here I'm going to be preaching to the choir, but now it turns out we're preaching to the Pope. Robert, you've spent a lot of years of this. Tell us, a little bit about what you have done and what you're doing these days, and just as it relates to comfort.
Well, well, I think most people know, I've retired. I actually shut my engineering business down 3 years ago. And somehow somebody found out I had some skills in construction. You never tell people what you can
I was
do when
supposed to
you're
tell them.
retired. After 61 years, that's the only thing I've learned is keep your mouth shut. So we're renovating some houses, and I'm looking forward to today's presentation because it looks like, a lot of things that you're going to be talking about, stuff that we're doing to bring these old houses from the 40s and the 50s back up to speed. And the big objective there was to make them so that they're comfortable. So I'm happy to be here.
It is interesting, isn't it, that your entire career, like you and I both started out probably in the energy world, and then very quickly realized, energy efficient doesn't necessarily equal comfort,
Right.
and people don't really know what their bills are anyway. What they really know is I'm cold or I'm hot or I'm wet or whatever, and so you've done such a nice job of I'm going to say quantifying that, and we're going to rely on Robert today to provide, I'll say, color commentary, the best of color commentary. Imagine if, let me see, who could it be? Wayne Gretzky is a color commentator. Let's go with that. That'd be great.
Happy to do it.
And then I'll introduce Stacy, and Stacy, if you would take us through some of the logistics.
Hi, yes, Stacy Cooper here, and the session runs from 1 until 2:30 today. And on the bottom of your screen, everyone should see there's a choice between a Q&A and a chat box. And for questions that relate to the topic at hand, we ask that you put that in that Q&A section because it gets recorded in a different way. And if you just want to say hi, or like one of the people online here already have made a comment in the Q&A. So we ask you to put that in the chat box because that's always fun that everyone can see that very quickly on their screens and can make their own comments about it as well. And when we get to the polls, we also ask that if there's anything that we're missing there, that you'll put that in the chat box as well. So keep the comments coming. They're always appreciated, but do be respectful with our speakers because they are putting in their time here from a very busy schedule. And we can always have you follow up if you want to as well. We can give out the emails if we don't get to all the questions in time. And as always, we will give you these links and presentation materials in a resource email that will come out once we've edited everything that we need to send out to everyone. And then at the very end is a Survey Monkey. We like people to fill those out because that's really helpful in letting us know if we're delivering the right content to you, if we can add to that. And we use that from these surveys. And I think that's going to cover it, Gord, from the admin side. And then we're off to the races for the first poll, which is where you are located. This lets us figure out how you use your Zoom buttons here. If you can figure out that you're from Ontario or BC, or maybe you're watching from Montenegro there. I think we had someone last time.
We've had folks from Texas from time to time. We've had folks from a good friend of ours from Texas, and even had somebody from Australia at one point. Our good friend
Armando always likes to tell us stuff about Texas, right?
Yes, exactly.
So I think that's good. I'm going to end the poll. And so we've got, most people are from Ontario today. Gord?
Still BC, pretty interesting. And Alberta, I was just out there at both of those locations and doing some work with Fortis Gas and in Alberta with a couple of large builders. So nice to see representation there. Nice. And one from the US. So thank you.
And then the next is, what is your occupation? So if we don't capture everyone here, please do put it in the chat box. Let us know if we're hitting the right target audience as well, right, Gord?
It's actually, and Robert, you had mentioned renovation, and obviously that's a huge comfort market. New housing, much of our work, and Angela's and our work is in new housing, but hopefully there are some renovators on the call because you'll be able to offer upgrade advice to them as well.
I'm looking forward to that.
So there's the results there.
Wonderful.
Oh, great.
Yeah, so if we've missed the other, please put that in the chat and let us know what occupation you have that's making you join us here today.
Great.
And last thing, I'm just putting this in the chat box right now, is we don't offer education points with these webinars. So I know that that disappoints some of our viewers, but that's a different conversation.
Stacy,
we're
can you just
talking
leave
about-
that up for a second? This is actually, these are interesting numbers, Gord. And so if you notice the HVAC contractors, we don't have them on board today, and that's fine. But what's really exciting is to see how many builders and developers and renovators, because normally when people think comfort, they're thinking mechanical. And the reality is these are building problems. And so I'm pumped about these stats here.
Thank you. I'm interested too. I will say, Robert, I've mentioned to you construction instruction down in Denver. We have a tremendous learning center down there, and we do an HVAC session, 2-day HVAC session, where we have a little 500 square foot house with 3 different mechanical systems. And it's builders who come because they need to learn more about HVAC systems. But as you say, we still do the basic building science when we talk about comfort and HVAC, because they're all integrated. And Angela, you're a big proponent of house to system. Everything impacts everything else. And as Robert's saying, is you don't want to just think about mechanical systems as the solution. And that's really the premise of today. What can we do in early phase of design to make this work? So that's pretty powerful.
It's good to see we do have a HVAC manufacturer present. Looks like Philippe Veras.
Oh, okay, yeah.
So that's interesting because we need them on board too to see what's coming and what products builders need.
Wonderful. Thank you. Let me see. Oh, there we go.
Small stuff.
In terms of our general agenda, we're going to speak till about 2:10, and then we will, so about an hour, and then it'll be, it will also be a time for questions at the end. And we always like to point out, just remind you, this session is sponsored and supported by Enbridge Gas, and I don't know if Susan's on the call. I know has been extremely busy as of late, but Susan Cuddy has just been a wonderful partner. Well, Enbridge overall, and Susan as the representative is an excellent partner to the industry, just really trying to help builders solve problems, create better housing. And so I was very appreciative of what Enbridge is able to do. You can imagine what they're going through in today's world as they react to rising gas prices, the comfort expectations we're thinking about, and then carbon requirements and energy efficiency requirements. So always good that they're helpful to our industry as we move through that. So again, as we get started on the presentation specifically, here's the topics that I thought we would chat about today. We'll start with a little bit, hopefully short conversation on what codes offer on comfort. We'll give a little bit of a comfort definition, because Robert, that's a 2-day course for you, maybe a half day at least to get the definition, but we'll have you comment on what is useful, at least as a starting point. And then Angela and I were chatting and thought, rather than talking comfort generically, why don't we look at the comfort pinch points? And these kind of line up with the questions we get when we're doing warranty investigations. Angela, we have, quite a few on the go, and almost all of them end up being related. When they're HVAC/comfort related, they tend to be something's wrong with my basement, the room over the garage is unbearable, my master bedroom doesn't provide an opportunity for a good night's sleep. And then I call them feature rooms, but I think, Angela, you would agree with me, mostly that's connected with large windows. And perhaps you could comment on that, Angela. Our designers have enough windows in houses or too many?
Well, we have a mix, if we're talking production builders versus custom homes, but we do see larger. But what we do see more of, if we're looking at the average, not so bad, but we do have rooms that have excessive amounts of glass for that look or for that water lake cottage view and things like that.
It's everybody wants that view, right? Even if it's a view of the next door neighbor, I sometimes what I'm not sure I like that view, but there you have it. And so what we're gonna do is focus on those 4, and then there'll be time for questions at the end if you want to talk about other areas of the house. But we thought that might be useful to you to think about those 4 areas. So I wanted to talk about the code, because this is when I'm writing a Tarion report, for example, a warranty report. For those who don't know, Tarion's the Ontario warranty program. Mandatory program. Here's what the code says. The code says at outside winter design temperatures, The system shall be capable of maintaining indoor temperature of not less than 22 degrees Celsius. And the National Building Code, the Ontario Building Code, the BC Building Code are all very similar in this. Notice there's no mention of cooling, no cooling requirements. That's not to say you can put in a cooling system and not do anything, because as you'll see here in a minute, when you do put in a cooling system, there are requirements around it. It's just not specified as to what temperature it shall be maintained at. So the 22 degrees Celsius, I don't know if the code says comfort, but as a number, Robert, I think you would say, in theory, 22 degrees Celsius satisfies the comfort needs, or at least it represents the a comfort target for a significant percentage of the population. Is that a fair statement?
So and by the way, this, if you read further in the code, this is actually an air temperature. And as those that have been studying thermal comfort over the years with me know, that we don't use air temperature as a proxy for thermal comfort. We use operative temperature.
Right.
So that's really important. And as you get into the standard's very diverse. A lot of people, will talk about the ASHRAE, and you're going to do this in a minute or two, talks about the restrictions, but the reality is there's a large band that you can use in a space for comfort. And because there's so many metrics, if you have a drop in an air temperature, well, then you have to compensate with a higher MRT. And now you're going to talk about some of these things. So it's a balancing act. This is a number to get you started, but it's definitely not a representation of comfort.
Thank you. I totally appreciate that. And as I mentioned, Tarion says 24 degrees Celsius down near the bottom of the page if you're selling the house with air conditioning. And there's some limited specifics on indoor humidity in part 5 of the code that talks about, in general, the building materials are, the way you build your walls are good for maintaining moisture up to 35% in the wintertime. But there's no really specifics from a comfort perspective on humidity levels, which is pretty critical. And then I did want to point out that the code in part 6 of the code, it says when you are doing heating, ventilation, and air conditioning, you're in part 6, and it does call out what they suggest is good engineering practice, and they call out things like the ASHRAE handbooks and standards, and that's an interesting one, and the HRAI Digest, which is a Canadian document that includes things like the Residential Air System Design Manual. So there are guidelines, including, for example, SMACTA manuals. You'll see point E there, which talks about construction of ductwork. So it's not the Wild West. You still have to follow good engineering practice. You can't say, well, the code doesn't say there's nothing for cooling, I don't have to meet any specific requirement. No, you're still subject to the metrics of and in the ASHRAE handbooks, the HRAI Digest. Although I wanted to make sure in this page it doesn't show the CSA F280 the standard for required capacity for heating and cooling. It is mentioned in other sections of the code. So the code is I love what Robert said, is a starting point in terms of a number, but it certainly wouldn't help you define comfort for all of your occupants, is where we want to head. I wanted to show this one. This happened to be a $700 a night hotel in the highlands of Ecuador, a 350-year-old hotel where Simon Bolivar, at that time the head of the I'll say the rebellion down in South America, he signed the Declaration of Independence, and so $700 a night. I didn't see any heating system. I'm like, I wonder how they're going to heat this place, because it got down to about 5 Celsius at night. Turns out the good news was we had a deluxe room, so we got not 1 but 2 hot water bottles. This was the sum total of the heating system for the entire place. There was some fireplaces in the central areas, and there was a fireplace in this room, but it had long since been decommissioned because it didn't vent very well. So we were left with water bottles. It was a luxury hotel, so in the middle of the night, if you did get chilly, they had put new hot water bottles out in the hallway, so you could run outside and get a new hot water bottle. But I just, that's, I would say we never used to heat the space. We used to heat the place, if you will, where you happen to be. So I thought that was kind of funny. But here's where, Robert was alluding to, that the definitive standard on comfort is standard 55, and it's a really good example, I guess, of all of the parameters that are associated with comfort. As he mentioned, air temperature is just one piece. The code mentions air temperature. We measure air temperature, but in fact, there are things to do with humidity, airspeed, and drafts, and surrounding surface temperatures. Robert gave you the acronym, mean radiant temperature, the surface temperature around, and I'll get him to speak to that in just a second. And then it's things like gender, age, activities of occupants, the metabolic rate, and even clothing. So what are your thoughts, Robert? Should everybody have a copy of this? Is it readable, or is it too advanced for most folks?
No, it's not. But what I would tell people to do is actually use the Center for the Built Environment's online 55 compliance tool, because it addresses everything that you see there in your list. And I think I certainly would encourage people to buy the standard. We put a lot of work into it to publish that thing, and of course, it's always kept up to date. But you take every one of those terms and others, and it really goes into each, the specifics of each term. So if you're a real dweeb, using Gord's terms, get a copy of the standard. But if you're not prepared to do that, at least use the tools. They're free, they're online, and they'll deal with it. Yeah.
We'll provide a link to that. The Center for the Built Environment, Stacy, you'll make note of that, and we'll provide a link to that for folks. I like the standard just even for the first 5 or 6 pages. It gives a pretty nice overview. I think it's 8 pages or something of the standard. I leave out the integrals, the differentials, and the calculus, but I like just the upfront piece of it. I think it's pretty useful. But and I want you to speak to this idea of operative temperature. You mentioned it before, and just give us a quick thought as to what that means, and more importantly, what that means to folks in this call.
Yeah, well, people have an intimate relationship with their environment, their spaces that they're in, and that's done through the sensory systems. And it's not just an air metric. We have this huge relationship via radiation. Between 50 and 60% of the sensible heat loss is radiation. So we have to have a term that describes that relationship, and that term is operative. And so when we use the term operative, we're actually talking about what is the person feeling due to all of the different surfaces around them, as well as the air temperature. And so that's what this operative temperature explains.
And in the graph on the right-hand side, you'll notice the shaded graph, or the shaded part of the graph, and those represent 2 different levels of clothing. 1.0 is CLO, is one level of clothing, sort of normal clothing. One is skimpier clothing, which my kids like to wear these days. They don't, I, as a Canadian, used to get flannel shirts and corduroy pants around this time of year, and now they're at shorts and t-shirts, so that might be in the 0.5. So even that falls into this. If we really wanted to know, we would ask our clients, how do you like to live in your home? And that would impact the temperature they live at. That chart there on the right is the psychometric chart, and it takes into account temperatures, humidities, and now we can see clothing levels, and gives you a range. And you can, as Robert alluded to, there's quite a broad range of where people might feel comfortable, and it's not just about an air temperature. On the left, you'll see what's called a black globe thermometer that is able to measure this idea of the surrounding surface temperatures. How close am I to a cold surface or a hot surface? The one in the middle there, the one I'm going to highlight, if you can squeeze into your screen there a little bit, this happened to me in Phoenix. We were out in our warehouse. It was 82 degrees air temperature in the warehouse. The operative temperature, though, or at least the feels like temperature, this is a fairly inexpensive heat stress meter that's used for things like warehouses so that folks aren't overheated during working hours. But in this case, the temperature, the feels like temperature, was 95 degrees. Well, what the heck's going on? Turns out we found out that day, it was the first hot day that we'd been in the building, that it was a steel roof, metal roof, that was not insulated in Phoenix. And it was 110 degrees outside. You could imagine no shading, and no clouds. The actual temperature of the roof was in the order of 120 degrees. And that was, because it was 12 feet above us, was feeling like, so we were feeling like 95. So the air temperature at 82 in Phoenix was actually pretty comfortable. That's not bad. But the operative temperature, well, you might say it wasn't the total operative temperature, but at least it was taking into account this effect of the radiant. Is that making sense? Is this a reasonable tool for folks to have, Robert?
I think if you're anybody that's doing forensic work, it's an absolute must to have a tool like this. And if nothing else, to be able to take potential clients into spaces to show them. This is the consequence of having, like we were talking earlier with Angela, with glass. There's a reasonable amount of glass that lets in enough light so that you have good lighting quality and good sound quality and good thermal comfort. But when you get beyond the reasonable value, then you start getting comfort problems, lighting problems, sound problems, and having these instruments can demonstrate that. So I think I don't know what you paid for that tool, Gord, but it's
750, something like that.
Yeah, so if you're doing lots of work, it's nothing to have a tool like that and a thermographic camera, and pretty much you got all you ever need.
I haven't found this one that useful for cold complaints. I found it pretty useful for overheating because it is a heat stress meter. Doesn't seem to be as helpful in cold climate, but maybe not big enough pieces of glass to really see the difference. But even a degree or two, I think you'd agree, a degree or two different Celsius can feel pretty different for clients. So I thought that was kind of interesting. And then I'd move you towards, because you have the ASHRAE standard, but then ACA, the Air Conditioning Contractors of America, have created a comfort chart. This isn't part of our code. It's not even one of the reference documents, but I still think it's kind of interesting to look at it. If you followed the chart down about 4 rows down, 5 rows down, you'll notice it's showing a maximum of 4 degree Fahrenheit difference between rooms and floors in heating mode, and a maximum of 6 degrees Fahrenheit between rooms and floors in cooling mode. In other words, what they're saying is when you design, and they use pretty much the same design methods as we do in Canada, ACA and HRAI, or companions, if you will, that they're saying the system you design should be able to keep a maximum of 4 degree temperature difference. I suspect people on this call, and you might want to show hands or put it in the chat and say, do you think your clients would be comfortable? Angela, I'll ask you, what do you think, you personally? 6 degree temperature difference between upstairs and down, do you think that would fit the needs of most of the clients we speak to?
Yeah, definitely. At that much difference, for myself personally, if you were to tell me it was 6 degrees, like, you might as well just keep me in the freezer. It'd be the same thing to me.
Right. And that's really what we're after here, is that although this is what mechanical systems in theory are designed to, they probably don't meet customer expectations. I often counsel builders that you should put this somewhere in your schedules to say, by the way, your system has been designed to maintain 22 degrees Celsius average, and I'm going to turn this into plus or minus 2 degrees Celsius as opposed to plus or minus 4. I think that's pretty interesting. The one I like is down near the bottom. There it is, the floor temperature. 65 degrees Fahrenheit, and this is important to me because we're doing more slab on grade, more finished basements. That foot temperature is pretty interesting, right? That as to where the temperature needs to be. So I think that's a pretty fascinating number.
Yeah, these numbers would not be, well, anytime you say a specific number, it wouldn't be in compliance. The floor temperature itself would be a failure in the local discomfort on standard 55. And the differences between rooms, that's also interesting because the thermal comfort standard actually applies to the person wherever they are in the place as opposed to the space. As Gord, I love that term actually. So the operative temperature actually follows the person. So where the person goes, so goes the operative temperature. And the differentials, that's interesting too. I mean, that has a lot to do with the building performance as well as the mechanical systems. And we know that when you have bad buildings and air-based systems specifically, that combination, you get huge stack effects, differentials that are easily in those numbers. I'm with Angela. When you've been into a properly built house, architecturally, it's great. The enclosure is great. The interior design is great. And you've got an appropriate mechanical system. And there's less than a half a degree difference between any place in the building. And I'm not talking just about a 1,500 square foot bungalow. I mean, I've been into large custom homes, and the environments are incredible if they're done properly. So
there's reason to believe we can do it better than this, but this is, I just want to leave people with the understanding that our normal design methods, this is what you get to, and you'd have to either admit that, or you'd have to say, to clients or your mechanical contractor, hey, we want to do better than this. So
Yeah.
that's useful. So I've put it into Celsius, and I've created just a base for comfort. This is the kind of thing that you'll see, yeah, you're going to get a copy of the presentation, and I'm going to put it in this range. The foot comfort 17 degrees Celsius plus or minus 2. These are the kinds of numbers that the Tarion, the warranty programs would have you work towards. I'm interested in the humidity numbers. Robert, you will know this. The Sterling chart comes from 1976 or something, and recently validated in COVID. But the idea that occupant health is really best between 40 and 60, and that's a great number. But in Canada, certainly in Calgary and northern Alberta and northern Ontario, we can't do 40, right? It would just be too much stress on windows and so on, and condensation. So we're more like 35 plus or minus 5, sort of nudging up to the 40 in the wintertime is where we want to get to. But those are the kinds of levels. So that's, I wanted to do a little bit of definition, a little bit of code before we got into the actuals. I will say to you, it is helpful new resources on the right-hand side. The new HRAI Residential Air System Design Manual was just republished in 2021. It has some nice changes, some helpful changes in terms of direction as to where codes fit, and then some really good optimal design parameters and so on. So I'd encourage that. And then I'll still call it new, F280. It was done in 2012, but there's still certainly in existing houses, and even in some parts of the country are not using the new F280. And I got to say, it's much much closer. I call it accurate. Maybe it's precision that the word I'm looking for. But these two items certainly help. And then there are lots of new strategies, new equipment, and specifically new controls that are going to help us along the path as we move. But I wanted to start with, I said 4 pinch points. I wanted to start with, and Angela knows this house. This was the house that was studied in CMHC's indoor air quality program years ago. But if I asked everybody on the call, as I often like to do, what are the 4 words that describe the atmosphere in this basement, and everybody gets it right. It's cold, dark, damp, and musty. And basements up until 1995 were never designed in code to be part of living space. I'll say that again. Building codes changed in 1995 in Canada to imagine that basements could be occupied livable spaces. Up until then, they were meant as basements. They were meant as storage areas. Nobody had the expectation in code that people would live there full time. And so if people are going to live there full time, we want to turn them into warm, dry, bright, and healthy. And how do we do that? And when you think about the challenges in basements, there's sort of 2 elements. You have all of these moisture sources. Living in the holes in the ground is not easy. And so when you're going below grade, you would say, I need to spend a little bit more money at it because of the soil dampness, the rainwater runoff, the construction moisture, the summer condensation issues. And then from a thermal perspective, you've got cold walls and cold floors, insulated, specifically the floors. The only thing that's separating you from Mother Earth, cold Mother Earth, is concrete, and the insulation value of concrete is like 0.08 per inch or something like that, in that range. And so we struggle to maintain thermal comfort, and you can start to imagine that mean radiant temperature of the ASHRAE comfort chart, and imagining that cold floor and what it's doing to not only your feet but to the rest of your body. The other thing, and Robert kind of alluded to it, is this is at the low end of the stack pressure. That is, at this point in the house, air's leaking in. If there is air leakage, it's leaking in. In your bedroom, master bedroom on the 2nd floor, most of the time air's leaking out of holes, but in basements it's leaking in. So you have cold drafts in the wintertime. And then recognizing that because heat moves from hot to cold and moisture moves from more to less, for the most part, basements are trying to dry to the inside. The moisture that's in the walls, the moisture that's below grade, is moving almost always from out to in. So we have that higher levels of moisture. So we have higher levels of moisture, and we have cold surfaces. And from an indoor air quality perspective, a comfort perspective, we can all imagine that's a challenge from where we go. I don't know, Angela or Robert, if you want to add any. Have I missed any yeah buts there that you guys wanted to? I'm just sort of throwing something at you. I should have asked earlier, but anything that I'm missing in terms of the comfort challenge in basements?
certainly from a thermal point of view, but everybody knows you get into these bad basements and you have an odor issue as well.
Ah,
And that can stick with you for a long time. If you've done any remediation work in terms of mold or mildew, wood rot, whatever, there's a huge odor issue.
and Angela, we've had that in some of our warranty complaints.
Yes, and I think one of the big things about basement, when I see the foundation, you talk foundation and concrete, and first thing that comes to my mind is cold cellars.
Right.
Yeah, right.
Potato salad.
That's what
And
we
they
want to
don't,
call them.
yes, and they don't work very well, right? They don't. I remember Joe Stebrick did a woofie analysis, maybe it was Armin Rudd did it for him and said, yeah, cold cellars can't possibly work. The physics would say they can't work. Basements might be able to work because you can add heat to them, but cold cellars or root cellars, whatever we want to call them, really can't work. The physics is really difficult. So there you have it. And then we would say it starts with from a design perspective, and I will ask Angela to speak to the one on the left. The one on the right is, I like playing it. It's, it just showing the level of detail that if you really wanted to keep moisture out is the drainage layers, the waterproofing and drainage layers that you'd want to be using in order to keep water away from that foundation. On the left, though, is the choices, one, the placement of insulation and the choices of insulation. I've said on this same webinar series before, if you go to the state of Minnesota, you're not allowed to insulate on the inside of a basement wall. All insulation, and I'm paraphrasing a little bit, needs to be done from the outside. And that has a real nice magic to it. It means the concrete surface is warmer. From a mean radiant temperature perspective, if the concrete mass is now warmer, would that help us from a comfort perspective? In this case, we're showing insulation on the inside, but using a foam-based insulation as opposed to a fibrous-based insulation, because we would say it manages moisture better. So insulate on the outside, I'm going to encourage it, but if you are insulating the inside, foam-based, even if we end up putting, and Angela, we see a fair bit of, they would put a stud wall in front of this and then maybe use a more cost-effective bad insulation. But in terms of, let's say, a net zero project, what levels of insulation, both the continuous and the bat, are we achieving typically in a net zero?
Well, in net zero and even along with Energy Star, it's really not that far off from the building code. We're looking for an effective 21.1 kind of range. So you're looking at, depending on the inches of exterior, or sorry, not exterior, but continuous insulation on the wall, you could be looking for, R5 plus an R20, R22 in front of it. Or if you're going to go the R10, 2 inches, and maybe you can speak to more about that, having the warmer wall, but having an R10, we're still at an R12, R14 with a 2x4. So it's not that bad.
So R10 on the base wall in a foam-based product, and then a 2x4 wall in front of that, let's say R12 or R14 bat. And so we have a much drier basement, the way that moisture is managed in the concrete with the foam insulation, less chance of condensation in the cavity, warm, moist air moving either in or out. Now the condensing surfaces are much warmer, so far less chance of moisture issues in that basement. And then insulation under the slab. And typically, Robert, R10, but if you were doing in-floor, I know your hydronics world, what level of insulation would you be recommending under slab, if with or without in-floor heating?
As a bare minimum, we would typically do 2 inches. But so much of that, Gord, depends on the soil connectivity. The characteristics of the soil and the water table play a huge role in downward loss. Unfortunately, most residential projects don't have the wherewithal to do geotechnical reports. They have a general idea in the development, but they don't really know under each specific house. So if you don't know, at minimum is 2 inch for us.
So R10, and you said minimum. Give them, because there's lots of people on this call would say, I don't want minimum. I want what Robert, the comfort expert, would say. What are your thoughts? Where's the
well, comfort wise, the 2 inches is going to get you where you need to go. The challenge would be, for example, like we have a property here that's on a lake, water table is really high. So if we've got a walkout basement, for example, we might go to in a really cold climate, we might go to 4 inches. But that would be a special circumstance where you've got water tables that are within 4 or 5 feet of the bottom of the slab.
But it does give us a nice range. I'm happy to hear you say at 2 inch, because Angela, that's basically the sweet spot for net zero
Yep.
as well, right?
Yeah.
And at 2 inch, you're telling us foot comfort, Robert, and flooring choices now tend to do pretty well. Is that a fair statement?
They're going to get you closer again. They're going to get you closer. And that's the flooring choices is going to play a role in that as well. There's a term that's called, anyways, it relates to the connectivity. So carpet versus tile versus hardwood, right? These all have a different impact on transfer of heat from the foot into the floor. So your more conductive floors are going to draw heat at a faster rate into that floor as opposed to, say, more softer materials. So we would look at that as well. But then you have to also think about, again, going back to moisture, what kind of flooring do you want in a basement that has a potential water damage, right? And so you want to use materials that could actually withstand some moisture. You know, we're not building a boat here, although there's some basements that need to be built due to hydrostatic pressures. But, you know, while we're here on this slide, I want you guys to be happy about this, because the building that we have up in Edmonton that we're looking at, it has water damage, and there's a potential that can happen again. So we've done exactly this. We've removed everything down to the concrete, rigid insulation. We're doing 1.5 inches, and then we're putting in steel studs, by the way. And then the first foot in the cavity of the steel stud will actually be polystyrene insulation, and then the top part will be rock salt. So there's a wall that, if it does get wet again, isn't going to require full demolition to do any repair work, which, you know, we've taken care of everything else. So if it is, it'll be groundwater related, coming up from the ground, and but the wall will be able to withstand some moisture attack for sure.
There's some interesting work in Louisiana because of floods, persistent floods, not necessarily in basements, but above grade. And Joe Steberg's worked with them, the Louisiana Center Disaster Relief Center, to think about walls that, kind of to your point, that can get wet and not get destroyed.
Yeah.
And then maybe I just cut out the bottom foot of drywall. And in fact, you might not go to drywall, or at least you'd use a paperless drywall, far less susceptible to moisture, the Dens Armor type products. And now you would have a basement that if and when it floods, and I think we could say over the 100-year life of basements are going to flood, at least now I can, with minimal work, I can restore that basement. So good insulation choices are a very positive, if you will. And so when you think about then the design optimization, one, it's optimizing that drainage. Two, it's foam-based insulation on the exterior walls, and we would say insulate on the exterior of the foundation. Again, I'll say, the basement studies done at the University of Waterloo and the University of Minnesota about 10 years ago now, maybe 15, showed that really exterior insulation would be a better choice. Minnesota just bit the bullet and said that's now our code. You can put insulation on the inside, but only if you first put insulation on the outside. And they've figured out ways to solve that in terms of the above grade portion. How do I finish the above grade? And if people need more help on that, by all means, we can send out some links. And then insulate the floors, as we're mentioning. This particular insulation and tape system is also approved for radon control. So we talked about odors, gases. Well, radon's another gas. You can't smell the radon, but we'd have to worry about gases. And then I'm going to say the product on the bottom right there is a dehumidifier built in to a wall cavity in, say, the basement, a bathroom wall or the mechanical room wall. In other words, all basements in Canada need dehumidifiers. And in my opinion, builders should start, rather than just saying, hey, go buy one, it's your responsibility. To my mind, you'd put one of these in. This is a great little product. It's quiet, it's built in, it's got its own control. And now you have confidence, especially if you're finishing basements, add it to the cost of your finished basement to add dehumidification that doesn't need to be, you know, buckets emptied and so on. So a useful part of it. So thanks. So that's our basement side. And then I will play this one because this is your renovation project. This is that idea of foam-based insulation on the wall, in this case an XPS foam. They're showing a spray foam. This, by the way, you'll notice the acronym on the bottom right. Many of you already know construction instruction. These are animations that have been drawn by my partners in the US on various elements. I particularly like this basement one and how it manages the moisture in both directions, that XPS foam and then the stud wall in front. Angela mentioned 2-inch. I think Robert might have said 1.5 inches. We would say certainly 1 inch, but 1.5 to 2 inch. 2 inches gets you to that net zero level. Stud wall in front. In this case, showing a blown-in insulation. Could be bats. You mentioned rock wool. That would be a nice choice. And you mentioned the bottom portion of that wall as being, you said EPS foam, I think you said?
Right, yep.
We like the extruded foam on the wall that manages moisture just a little differently than EPS. So on the wall portion, you'd like it to be an XPS foam, and then EPS in the cavity is fine at that point if you will want as well. And again, the magic is how it stops moisture. The XPS stops moisture from migrating from the concrete into the wall, and moisture that's moving from in to out. The first condensing surface that hits is no longer the cold concrete, but rather the warm foam. You'll notice on that wall there was no poly put on that wall. And if you have the right balance of foam, and it's in the order of 1.5 inches in most climate zones, some 2 inch, then you do not need a poly vapor barrier. That is, the foam itself is your vapor retarding layer. So that's pretty useful. And what's nice out of this, if we did our first pain point, finish off our first pain point of basements, I always like to highlight the benefits. We know the basement's now the home office, it's the school classroom, it's the fitness center. In many cases, it's the church. I've seen really ornate prayer rooms and other elements. People would say to me, it helps me in the affordability crunch of houses across the country. It helps me afford the house, and it's clean, it's fresh, it's healthy. And then Angela would say, and it helps you on the path to net zero because it gets you in the range of 3 to 5 gigajoules of energy reduction over and above minimum code requirements. Angela, is that a fair number? If we said you took a typical basement wall at R12 and went to net zero levels, 2-inch foam and 2-inch foam under the floor, you'd be seeing that in that order of 5 gigajoule reduction?
Yep, for sure.
Which is pretty powerful, right? When you think about, I always say the challenge to get to net zero from code is about 40 gigajoules. I got to find 40 gigajoules. And if I can find 5 of those gigajoules out of a basement and create a healthier space, I'm in really good shape. Anything I've missed? We talked about dehumidification, in-floor heat. Robert, anything we've missed from your perspective?
Other than just, addressing the ventilation that's required. I mean, now you got people living in that space, and you're gonna need to look at bedrooms, and if there's any food preparation, bathrooms, make sure that we're ventilating. And once you take care of that, you've got some really nice spaces to live in.
Truly livable space, right? And people say, well, that's expensive. It's not expensive when you think it's the office, the classroom, the rec center. People are spending more time down there. Thinking about cost per square foot per time of use. You spend a lot of money on a dining room and use it maybe once a week. You do a really nice basement and you use it for 3-4 hours an evening. Boy, that's really good dollars per square foot per time minutes spent is the new metric I would ask you to think about if they're going to use that space. So that's point number one. Point number two is room over garage or rooms over unconditioned space. I love this picture because you just know that room is seen as, in the US they call it a bonus room. In our case, we just call it floor space, and it's pretty ubiquitous now, right? You have the big garage and immediately put something over top of it. And of course, the challenge here, specifically on this one, you have more exposed surfaces, right? You have not only the normal ceiling and maybe 1 exterior wall, maybe 2 exterior walls. Here you have 3 exterior walls, the way this one juts out, plus the floor. You've added to the total heat loss, if you will, and total heat gain of this room. At least there's not huge windows, but we still have the windows to think about. And inevitably, this is a longer duct run because clearly there's no basement underneath the garage. So now the duct run is up and over and through and by. So long duct runs, which means it's losing temperature, losing airflow, and losing temperature along the way. It's not unusual for me to see 5 to 8 degrees Celsius drop in temperature. The temperature coming off the furnace is 40 degrees Celsius, 45, 50 degrees Celsius. By the time it gets to this room, it's only at 35 degrees Celsius, which means it's heat content of that air, the job it can do to heat the rooms, gone down, and typically restrictive on airflow. And furthest from the thermostat, and we will all know that the problem is the thermostat is buried nicely behind that front door, walk in about 10 feet, turn a corner, and there's the thermostat, and the thermostat's near the refrigerator. It's near the kitchen, the stove. It's near the big screen TV, the gas fireplace, and that room over the garage is seeing significantly different heating and cooling needs off there. Robert, I see you leaning forward. Any comments? Is this the bane of your existence from a comfort perspective?
Certainly one of them. Those and cantilevered floors.
Yes.
Yeah.
And yeah, even managing the air leakage on that floor is significant. It's pretty powerful. Angela, from an energy rater's perspective, energy advising, it's not a significant, the floor isn't a significant contribution to the overall heat loss of the house, but I think you'd agree, from a comfort perspective, it gets really challenging.
From an energy standpoint, it's looking at the insulation that's in there. It's not really looking at much more than that. But when I look at this room over the garage, and I look at the basements that we were just talking about, and you have a lot of renovators on the topics today too. At least this space, I can now renovate it. I'm just going in there, and potentially I can take down the ceiling of the garage and work on it. And could be like an easier fix. When you're talking basements, whole different ball game.
That's a really good thought. Thank you for that. We know there's hundreds of thousands of rooms over garages weren't done well through the 70s, 80s, and 90s. And you're right, the work can get done from underneath, which makes it much easier. Yeah, you got to put the car in the driveway for a couple of weeks, but at least we can get it fixed. And the challenge, of course, is that distribution of air, that long length. Notice the middle of the house, the thermostat's way over there in the middle left, if you will, and that bedroom, how much air do I need? And you really need to think about if the temperature coming out of that duct is 10% lower, 20% lower than the temperature coming out of the duct in the kitchen, I need 10 to 20% more air getting to that room. And my furnace system has to be at really good pressures. That is, we've designed for this longest run, we've designed a specific pressure in the furnace supply plenum to drive the air to that furthest point. And yet, I often measure the pressure coming off the top of the furnace. It was designed at, I'll throw a number at you, 0.15, but it's only 0.08. It's half the pressure that it was designed to be. And that pressure is important to get the air to the room, specifically the longest run. And if I have half the pressure, I have far less air that's actually going to travel to the end. So interestingly enough, the rooms that are closest, we have to actually think about balancing those down to increase the pressure in the duct system so that I get more air out over the end of the longest run. So it's pretty powerful to think about, and that's a huge comfort challenge. And so I'll give you a couple of thoughts from a design perspective. One, more insulation, because it's more surface area, and choosing the right materials. This sketch, the bottom left, is drawn by Joe Stieberg at buildingscience.com, and he's suggesting disconnecting the floor from the insulation, so that from a thermodynamics perspective, and Robert, feel free to comment, that airspace between the floor and the insulation, that airspace is now connected thermally to the room, not to the garage below, if you will. And we did this for years. They put a plenum up above in many markets, and they tried to force air into that plenum. It didn't work very well because it was fiberglass insulation and so on. I don't necessarily need to put air into that space. I don't need to heat that space. I just want it thermally disconnected. I will ask, Robert, your thoughts on that particular design. I'm using Joe here, and I'm asking you if you would agree.
I'd hate to disagree with Joe.
Go ahead.
Well, because the bad insulation is full of air. That's what's in bad insulation.
Right.
So you have a lot of air there already. I guess what it does is it removes some of the mass that would normally be there if it was fully, occupied with insulation. So by dropping it down or having less in there, you do remove that mass, which is a form of conductive path to the floor, right? So this was actually a strategy that we saw a lot in the early days of radiant floor heating, right? Where they would put the tubes on the floor, drop the insulation down, they would create that air cavity. That was done for different reasons, but the same effect. Yeah, obviously it's going to have some way to disconnect the two floors from a conductive point of view. I'll just leave it at that.
Well, now, here's what I'm going to say. I'm going to agree with you and say there's a couple of things I haven't mentioned, and I'll put it on the slide before I send it out to folks. You want to baffle this down. This is not bat insulation that we're showing here. Or if it is bat insulation, then I'm saying fibrous insulation, then you would want to baffle it down. So you would use, and actually a good colleague of mine uses a polyisofoam. Why? Because it's got a foil finish. Doesn't use it for the foil finish, other than he scarfs it and folds it down, shoves it into that cavity to create a nice 1-inch space with foam insulation, then bat underneath, and then rigid insulation below. So that in that case, the air isn't connected to the fibrous insulation. So that stops at least the air movement in the fibers. Would that help you a little bit? Would that give you a little more confidence?
That would, yeah.
Obviously fiddly to do. Some would say, well, I'll spray foam, and we would say, fair enough. Spray foam up to a baffle, a cardboard baffle. Use the same chutes that you might use, for example, for attics, and you would put those chutes in, or OSB. If you're using a wood eye joist, you would basically put at the bottom of that eye. Then you would use a piece of scrap, I'll say OSB, or thin ply sheathings, those kinds of things to create. And I don't want air movement. I don't want you blowing air into that space. We just want to disconnect. It only has to be an inch or so just to disconnect that space. So an interesting idea to disconnect, because often in the southern climates, like Ontario, I'll say southern Canada, they'll do spray foam and it works pretty well. You get north of Ottawa and Edmonton, the floor's still cold, and that's because that, as you said, that mass, that insulation, the conductive loss straight through the insulation. So that's some of the design options, if you will. The next would be, could we just have conditioned space? Why are we doing these spaces over unconditioned space? It's always difficult to do, so you might try to limit that. From an HVAC perspective, we have some choices. We could air seal and insulate the ducts better. I'm a huge advocate for AeroSeal to make sure that we've got proper airflow to these locations, and perhaps insulate the ducts better, even in the basement, just to retain that temperature difference. You might want to think about independent heating cooling system. Nothing wrong with saying, I'm done. I'm just going to do a separate mini split. It would be one choice, for example. There's other options. Or thinking about zoning of those situations. And even a poor man's zoning in today's world, lots of thermostats now have a remote sensor, and you'd put the remote sensor in that room, and when it's occupied, it gives a little more, it makes the whole house warmer, but at least it gives a little more temperature attention, if you will, attention to the temperature up in that space. So a few choices to get that done, starting with better insulation, disconnecting the floor, and then better mechanical designs, duct sealing. If I'm gonna be really blunt, ducts leak. Every duct I've ever measured, every duct system I've ever measured, even now that we do duct sealing in houses, is 10 to 15%. So 10% of the air that you thought was coming out this duct isn't coming out, and it's 10% lower temperature, so we're already up against it in terms of managing comfort to those spaces. So getting those things done. Third pinch point is, I said master bedroom, but I'll call it critical room. In some cases, that ends up being a specific child or member of the household. Maybe it's an elder that lives in the house, and so on. But in the case of master bedroom, the challenge is now, because of the 2 occupants, tends to be more of a humidity and air quality, maybe sound, and to some extent a control. They just want control. And Robert, I would just ask you to speak to briefly the indoor air quality challenge, if you will, or the extra burden, the fact that it's 2 people in that room.
Yeah, and it's when we looked at these types of spaces with our client base, and these were people that were building their retirement homes, we also drew attention to the fact that as individuals age, and this doesn't apply to everybody, but a large percentage of people lose the ability to maintain hygiene in these spaces. They spend more time in them. They're not able to maintain the hygiene in the space, whether it has to do with laundry, towels, whatever. And the fact that they're just occupying it more, you get much more body effluence into the space. And so they become a source of odors. So and it's interesting, Gord, you talked about the new or the ventilation standard, and I don't think we ever address the continuum of occupied houses as it relates to air quality in these type of spaces. We start with sort of a minimum requirement. We don't say, okay, well, what happens to this space over a period of time if people stay in there and age, right?
Right.
So humidity, let's just start with the first one there. I mean, you talk about two people in a space, likely an attached bathroom, shower, there's a huge source right there. So you have to talk about really effective bathroom exhaust systems. We tend to use more variable speed systems when we were practicing that had high capacities. Some of these bathrooms that we did had 250 CFM exhaust. People might get shocked about that, but you're running them not at the 250 unless you need it. And that could be to purge a space quickly, right? That type of stuff. Air quality, again, you have people sleeping and they're not aware of any particulate, any gases, the types of stuff that can be into a space. So looking at maybe higher ventilation or higher filtration in those spaces, in-space filtration devices. We see that a lot with COVID. A lot of people are starting to put their in-space ventilation or filtration devices, improving the air quality. Sound is huge. We know sound has a huge effect on people's abilities to have good sleep. You can't do too much about your partner snoring, but
So it is, and thank you for that, Robert. It is interesting that extra challenge. I love what you said. The aging, the ensuite being right there. That's that extra level of moisture, and they close the door and at night preparing for sleep, and then in the morning getting ready. Boy, there's a good 8 hours, 10 hours of pretty wet, pretty moist, if you will, pretty packed in. So it is from a comfort perspective. We see this, and I often find in these cases, they manifest as cooling issues. They say it's too warm in the space, but when I look at it, it's actually humidity. When I measure and monitor, I look at the humidity overnight and go, wow, it's 65%, and that's impacting comfort, right, on your, and so they don't necessarily recognize it as a humidity problem, but it's because the humidity level's rising because of the occupants in that space. So pretty powerful. And so we would think about, so in terms of cooling loads, the appropriate window choices, because master bedrooms often have, well, you saw in that last picture, that large patio door happens to be facing west, by the way, with very little overhang. You don't know that. But so I'd really want to think about appropriate window choices. Maybe it's additional insulation, just from a comfort. I'm showing the right-hand side, the idea of different sound attenuation. We know, for example, two types of insulation, a foam and a fiber, has a better sound attenuation. So all foam walls tend to exacerbate noise problems from the outside. So you actually like a couple of different types of insulation on that exterior wall. Some foam, some a mix and match, if you will, of cavity versus exterior, some of it fiber, some of it foam, for that sound attenuation. And then I'm going to say accommodate mechanical enhancements in that room. And one of the first things that I want to talk about is, should we create, and kind of to your point, of a little bit of an oasis? These are the people who are paying for the house. So could we, either through zoning or through a separate heating cooling system or a separate ERV and HEPA filtration system? We've been doing for a long time now fresh air from, say, an ERV simply into the furnace return. You go, but how much of that actually gets to the master bedroom? It needs twice as much air as the other bedrooms, for example. So could we do direct ducted? And now there are ERVs that have HEPA filtration or MERV 13 or better filters put in them. And could we direct duct? Is it time to go back to, in that location, specific fresh air to that bedroom? And I'll just ask for your thoughts on that as a fully ducted, for example, ERV or HRV. What do you think, Robert?
I got to tell you a story. When I graduated in 1983, my mentors taught me one thing, and that is that we have a separate heating system for comfort, and we have a separate ventilation system for air quality. And all the jobs I've ever done, Gord, my entire life have been direct ducted, direct ventilation systems. Have never done anything else but.
Isn't that interesting? And I did it in my house, and it made in my cottage, made a dramatic difference. It's quite interesting to see how people sleep differently when they have that fully a fresh air. Specific in this case, just showing it to one bedroom. This is showing a mini split as a individual heating cooling system. Wouldn't have to be a mini split, but the idea of separately ducted from an air quality, humidity control perspective in that master bed. And you know, we're seeing master bedrooms. Angela, you and I are seeing plans where it's not a master bedroom. It's a master bedroom complex. Is that a fair statement?
Yeah.
Yes. 2 walk-in closets, 2 dressing areas, 2 bathrooms, you know. So in those kinds of spaces, I would encourage people. In the interest of time, we'll move on, but I think master bedrooms, there's an appetite there, and you've heard Robert's been able to do it successfully in his career. There'd be an appetite there to change the conversation, to say to folks, especially as they're aging, to say, you deserve this. I love that phrase in a sales context. You deserve this. This is a beautiful looking master bedroom. You're clearly going to spend a lot of time here. There's a reading area, there's so on and so on. Let's give you something specific to that area that manages that humidity, the air quality, and the temperature. Really, really powerful.
Yeah.
Really.
Gordon,
Gord.
I know we're short of time here, but people need to also understand that when you're doing the architectural design of these, to think about natural ventilation and their window choices, the way they're oriented, how they open up, and then also think about your clients as they age, they develop arthritis, they may have physical disabilities. So when you do these spaces for people, think about how can we use the natural elements outside, the predominant wind patterns, pick the right kinds of windows, you know, make sure that you've got the ability to create a sail for the wind to be captured, drawn through the space, and then relieved out some other side of the building. So you have to think about these things as well.
Very nice. And Angela, you had a comment?
Yeah, I was just going to say that the other thing that we've been seeing change, and I see Mike O'Rourke from HVAC is also on our participants now. So we do have a contractor or a designer here. But what we're seeing is farther distance to that master bedroom. So we're seeing 3-story and a basement. And now what are we doing?
Yes. So another reason, if it's way down the end, why wouldn't we have a separate system? So thank you for that. That's great. And then the fourth pinch point, this was a warranty claim that I was just working on last week. These are luxury condominiums in a quaint little town just north of Toronto. We know what these, you'll have a sense of what these are worth, and notice those units and the amount of glass. And you know that these were featured, right? This is what people paid for. And on the 4th floor, 4th level, if you will, this client is challenged with cold and hot surfaces, the intermittent loads. His complaint literally is, and their complaint is, and he has, they're elderly. His speaking to your point, she has some health issues at this point and doesn't have the ability to kind of control her own, I would say monitor her own bodies and body comfort and so on. And he said it's just swings. The temperature swings are just so dramatic, and no opportunity for shading in this building. You might say in some buildings that I could shade it with trees or awnings or something, but just really difficult. And that comfort challenge, back to your point of that, you mentioned the 50% radiation, the radiant loss, that our bodies are responding to that radiant loss, Robert, which is really interesting. And yet in this space, this room, only measuring air temperature and yet not impacting or thinking about the surface temperatures and how they change day to night and seasonally. It's very powerful. And Angela, this is always the conundrum, and I know we've covered this on other calls, so we'll go fairly quickly, but the energy programs still love that heat contribution from the south-facing glass, but you and I would say this is kind of the bane of our existence from a comfort perspective. I'll let you speak to that just as I move along, but.
Yeah, it's just in the programs, we just love the high solar heat gain because we're thinking about winter and the gains from the heat. But comfort is not part of energy programs, to say the least.
And understanding that the windows may help you, and we don't spend a lot of time in cooling in Canada. It's weeks, not months. Maybe it's more than weeks, but in terms of the size, and you mentioned Michael O'Rourke, a good friend of the industry, and Michael will guarantee you that the windows account for 50 to 60% of cooling loads. So, and that's an intermittent load. It comes and it goes. And we've pretty much doubled. The window wall ratios used to be 6 to 8% at national average. Now it's 13 to 17% national average. What's the biggest one we've seen lately? I know I saw one at 42% window to wall ratio in a house recently. I don't know if that was one you showed me, Angela, but
Well, I know our highest is 62%.
62% window to wall. These are exhibitionists, I presume. I don't know where they're from, but and maybe there's not many of those, but there you have it. So it's a huge challenge, and I just wanted to show. Oh, sorry, this is going to be slow going. I forgot to take off these animations, but here's a house, or sorry, a 5,200 square foot house, and the glass within that house, and facing southeast and southwest. That the way that house is faced ends up being 12,000 BTUs. If I go to 0.4 solar gain, this is all showing the difference between the solar gain in houses or windows. Now we're down to 8,300 BTUs in the worst case, and if we get down to 0.23, that house is now 41,000 BTUs. And from that perspective, I'll just show this. It's to the cooling load associated with that southeast southwest window. That's a ton of air conditioning. That's 400 CFM of air. Whatever room that's in, or collection of rooms, that's 400 CFM of air. Versus 4,100 BTUs, that's 135 CFM of air. You think about the number of and size of ducts. The one on the left, that's 4 6-inch ducts. The one on the right, it's 1, maybe 1.5, 2 6-inch ducts. So from the practical perspective of managing and understanding that every time you're adding glass, you've got a couple of choices. You're either adding ductwork and tonnage, or you're thinking about solar gain. And this is, like I say, we've covered this on many calls before, but it's at least getting us down to the lower solar heat gain coefficients. We know that the window manufacturers, don't know if there's any on the call, still struggle to get this information out to builders and be responsible. Responsible sounds like they're incompetent or something. They're not. It's just the focus has been in Canada on the solar gain as a good thing, and we're suggesting that the solar gain is a challenge. So we just need to think about getting to that lower solar gain and thinking about its impact. And Angela, I'll ask you to speak to. Does it impact negatively, significantly, the energy rating of a house?
Yep, absolutely.
It does.
It can.
It
It
can.
can.
So if you're going to use low solar gain glass, you might have to add a little extra insulation somewhere else. Is that a fair statement?
Insulation or other items. Yep.
Yeah. Air tightness, for example, those kinds of things. So Robert, I'll say, when you were doing in your work, did you see A, the rise in amount of glass, and B, how did you accommodate it?
Those were always interesting discussions. The design charrettes, when you're sitting there with the architect and the client and the design team. But we would always come from an approach of that every architectural decision has a consequence thermally, and that it just takes people who are reasonable to understand that. And we would use the tools to show the differences when we would look at, if you just make a different choice in your windows, the consequences on thermal comfort. Do you really need that much glass? We could show them that daylighting factors, you could get better daylighting factors actually with less glass, better thermal performance with less glass, but a higher performance. And you wouldn't need to have as much shading that would otherwise be required for comfort. And so you're looking at the outside, you're looking at the inside, you're looking at the client's needs, looking at what the architect wants to achieve. But ultimately, when you can demonstrate that you're going to be uncomfortable in this space if you continue down this path. So and you don't have to fix the entire building. You just have to fix the problem, what I call the rogue zones. Those zones that are creating the problems, address those, and you don't have to do the whole building. Just, yeah.
See, we should have talked before, and I would have used rogue instead of pinch point. So yeah, I love that term. Thank you. The rogue zones. I think that's really valuable to think about the oasis. I use the word oasis to think about specific rooms where you know people are going to be challenged. It's one way to look at comfort, is to say I don't necessarily have to change the whole house. I need to recognize, and Angela, I think you would agree, that the energy, just as a starting point, obviously the HVAC designer is going to look for these pinch points too, or the rogue zones, but the energy analysis helps find those rogue areas as well, right? As you're doing your energy work, you tend to notice and find these pinch points or rogue zones. putting words in your mouth, but I think
Well, I would say that that's an energy advisor role when they're looking. It's not necessarily about the energy model itself, but the energy advisors looking at that plan set while they're doing the energy model, looking at the whole house as a system. And so they may identify those rogues.
yes. Thank you.
And just so
Is that a new word now? Rogues.
Yes.
And we're everybody here on that's presenting, like, we live the words we speak. I just finished the house I'm in now, my retirement home. It's a 1950s farmhouse. It's on a lake. And we spent the last 7 months, we removed all the glass out of the sunroom because it was a nice space. And you can see in the screen behind me, we left all the wood arches, but all the glass was removed. And the reason was because it was so uncomfortable and it was so bright and it was so loud. On the lake, the boats are going by, the glass just transmits that sound. This space has been changed. It went 180 degrees. I can be in here in the wintertime with my shorts on. I still have a beautiful view of the lake because I have a window at the very end of the space, but it's not 100%. It's probably like 40% of the wall on that. And then the small window behind me, so I have natural ventilation. I got the free air coming through for cooling and fresh air if I want. I got rid of the glass and my walls are warmer. And we've done that for all the houses that we work on. So this isn't just an academic dialogue that we're having. We live this stuff.
And thank you for that. And it's very good that the architects are on the call, because I think they would agree. It's a pretty important message. We've been going to more and more glass, and you've heard Robert say the foremost comfort authority in Canada. Going, you know what? Maybe you want to go back to a little less glass, still give the great views, but a little less glass, just so that you can enjoy that space. And so I'll just summarize quickly, and then we'll go to questions. Stacy, I'm sure you're ready for us. But understanding that the expectations have changed with respect to comfort, we tried to show that code doesn't address it much. There's some thought on where at least a starting point of 22 plus or minus a couple of degrees. But we know that our clients are far pickier than that. But the nice part is the same things that you do for energy efficiency also tend to improve comfort. So you think about air tightness in the basement, so you don't have that draft. You think about better insulation choices, both for sound and moisture control. And then you think about proper window choices, sizes, types of windows. And then lastly, mechanical enhancements. We think we can get this done, and I think it is encouraging when you hear an authority like Robert say, we can get this done. As long as we're respectful of and understanding that every architectural decision has a mechanical attachment to it or an energy attachment to it. That's pretty powerful. So thank you, Robert and Angela, for chiming in. And more importantly, let's get to questions. We've got about a little less than 15 minutes for questions. Stacy, get us started.
Zoran wants to know how many builders avoided below porches, exterior stairs, percentage-wise. So that was about the 140 mark when you're talking about the cold cellars, he's saying.
Oh, so read the question just again.
How many builders avoid it below porches, exterior stairs, percentage-wise?
Oh, that's a good, interesting one. Angela, any thought these days? What percentage of houses would we see have a cold storage room under a porch?
Well, I don't know so much about porches, but most of the plans evaluations that we do are still including a cold cellar.
Still include a cold cellar. And
maybe not in a townhouse, maybe not in a back-to-back, but definitely in the detached.
Wow, interesting, right?
Sometimes optional, but
sometimes optional. So there's your answer, Soren, and we would say, from a building science perspective, be ready to turn them into conditioned spaces, because they just can't work, or at least physics-wise shouldn't work. Sometimes they happen to work, but the physics would say they won't work very well. And definitely never, ever put anything in that space that could go moldy. So it's got to be plastics and steel. Steel's going to rust, but plastics. Anything you're going to put in there is going to be plastic. No wood, no drywall, so on and so on. Good.
Okay.
Next question.
Jim wants to know why foam instead of Rockwell comfort board or gravel for interior basement continuous insulation?
And it's a really good question, and I have huge respect for Rockwell, and I'm going to say they're going to support me on this. The foam-based product does a better job of managing the moisture. The Rockwell, the good news is it's highly permeable. The bad news is in this application, it's highly permeable. So any moisture that's in the concrete continues to come through that mineral wool product. You'd want the moisture to stay in the concrete. The concrete itself doesn't mind being wet or moist. So you want the moisture to stay there and not come into the cavity wall. The reason you don't want it in the cavity wall is because it's changing temperature, that moisture as it moves through that wall, or one way or the other. So you'd prefer to use a foam-based product or impermeable, maybe I'll put it that way, because if you wanted to put a facer on that and to stop the water vapor moving through it, that would be possible. But then you're back into needing a specific vapor retarding product.
David wants to know, in older homes, especially in Hamilton, where some houses are 3 feet apart, I've seen Delta waterproofing installed on the entire wall on the interior with an interior weeping tile system. What is the best way to insulate?
Good question, Robert. I don't know if you've had experience with that. There's absolutely no problem. If you can't get to the outside, internal drainage layers are absolutely possible. Stebrick's done it. I've done it. Stebrick's written lots on this. Other folks as well. George Brown College, I think, has good pieces on it. And so entirely possible. So drainage layer on the inside to an interior drain. And then again, to my mind, you're still back to a foam-based product. Many would say I'll just spray foam to that. In the case in the basement crawl space, we did drainage layer, and then I actually did use a mineral wool product with a facer that is fire rated, so it's a white facer. That it's a crawl space, so we didn't need to finish it, didn't want to finish it, and it made for a really clean dry base crawl space in that case. So it was still a fibrous insulation, and it had a facer on it. Didn't want to use foam in that location because it was a crawl space, and then it would have to be fire rated. If you're going to use foam, then it's got to be fire rated, so an intermissient coating or drywall in front of it or another insulation product in front of it. So those would be the parameters. But the idea of an interior drain, not a problem at all. Robert, any thoughts? Have you gone through?
I would just add that even in these types of buildings, exterior surface drainage is still possible. And we've got a renovation up in Edmonton, very similar, narrow space between the buildings, but we did regrade it. And then regraded the natural soil that's there, took crushed gravel, compacted it, so we had a really good slope. And that slope actually went to a French drain that was, and depending on how far the distance was, but it was well below the high level against the foundation. And then on top of that, we put the Delta mat, an impermeable membrane down it, and then put gravel over top of that, and then paving stones as the walkway. And
I like that. In other words, don't give up on exterior.
No, don't give up on the exterior, because if you can keep the water from getting into the grade and coming down the foundation, that's a good thing. So there's still the things that you can do on the surface to deal with surface water. The interior surface water from the ground up, that's a little bit different challenge, and the interior drains there. I don't have a lot of experience with them, but we are considering them for one of the buildings that we're working on up in Edmonton.
It's worked really well. That same Dorkin product, for example, the dimple drainage layer. There's others as well. And then digging down, again, two of my sons have gone through this, and it's done remarkable benefit. And then insulation in front of that. It can be fibrous. We prefer foam-based, assuming you're going to finish it, foam-based. If you're not finishing, the challenge is the fire coating or the fire rating that you need to worry about. Next question.
Okay, Morella asks, does it make sense to install the drainage layer on the inside of the concrete foundation wall if the house is existing and landscaped?
I think we just answered that one, so that's good.
Okay.
And it can be done either way. Robert said, don't give up on exterior. It's not that disruptive, so you'd prefer to do exterior. Angela, you have some experience with this, as I recall. Exterior drainage.
Yeah, it can be a challenge, that's for sure. So in renovations, especially, you might have your different foundations types within the same foundation. We were unfortunate to find a home that had a rubble foundation, so that has its own challenges.
Right.
And then finding the contractors to be able to achieve what you're looking for in the format with the products that you'd like to is also another challenge. But
absolutely.
Well, Morella adds, if there is a grade entrance parallel to the wall, it's almost impossible to keep that house wall dry.
Absolutely. Yes. Very difficult.
Okay, Zoran wants to know, with regards to the solar heat gain coefficient, what do you suggest in the Toronto Hamilton area?
Angela?
We just had an extensive conversation on this yesterday. Well, first, it is going to depend on the situation where you are, but we would be looking for a solar heat gain in the, you know, it's as low as maybe 0.25 up to 0.42. That's cutting it even a little high, but 0.35 is a good number.
Yeah,
0.35 is a
0.25
good number.
I like a point, no higher than 0.35, I think makes sense in an Ontario context. And then if you're kind of, I'll say the rogue windows, big windows facing west, lower, 0.2, 0.18. So it's really about the orientation. If everything's facing north and you're a bunch of trees, okay, high solar gain, nothing hurts you. But even from a comfort perspective, Robert, being able to, the radiant energy coming back in the wintertime, help us with that. Does the coating impact the way our bodies transmit energy? And what would be your thoughts on the right solar gain?
Yeah, so I'm with Angela, but I'm more on the lower side. So if we can get below 0.3, then we'll do that. And again, real life experience, when you know this stuff and you apply it, we have a beautiful view of the lake that we obviously didn't want to lose. And we do have a large window there that, I'm trying to avoid being a hypocrite, but we are that person. But I'll tell you this, the window that was in there before, double pane, lost its charge a long time ago, very, very uncomfortable in the summertime. Like almost to the point where you couldn't actually enjoy the space, even with the blinds closed, because we were measuring blind temperatures that were easy in the 90, 95 degrees with the blinds closed, right? Because of the solar gain. Changing that window this summer, high intensity, midsummer sun or midday sun towards the end, like 3-4 o'clock in the afternoon, we were able to stay in that space, enjoying the view, wearing light clothing, ceiling fan on without any solar control on the outside or on the inside, just having the proper glass.
And what was the solar heat gain coefficient?
Those were 0.28 or 0.29, something like that.
So I think hopefully that answers the question. Depends a little bit on orientation, but start off thinking 0.35, no higher than 0.35. And it's at 0.4, but 0.35 is where I'd put you. And then if it's big and it's west and it's no shading, then you're down around under 0.25.
Yeah, somewhere I've got all the spec. Oh, here they are here. Sorry, 0.22.
Attaboy, thank you.
0.22, we got a U factor of 0.15, visible transmit, it's 0.50, condensation resistance value of 73.
Oh, wow, huge. We didn't even talk about that one.
It's good we didn't even talk about light either.
But it makes a difference. You can be in the space and not be overheated and not be so cold and enjoy what you have. But there is science behind it, and you have to think about it.
Good. We have about 1 minute left, and we want to do just a little bit of a thank you. Okay. And so was there one more question?
Yeah, just David, follow up. Does zoning make sense in smaller homes with bedrooms in a one-story house with 2 bedrooms if it says 800 square feet?
Well, I think more and more people, to my mind, you build a really good enclosure, and zoning doesn't make as much sense or as much difference. Think about the usage of those spaces. It's really about that, right? About space versus place. Who's using it? When are they using it? That becomes your reason. If you've got a really good enclosure, the heat's very even throughout, especially if it's a single story. So I'm going to ask you to make that choice separately based on the occupant loads and so on. Nothing wrong with having zoning, and more I think we're going to see zoning strategies, and not just ducted zones, but little different types of heat, a little radiant heater over here and a mini split over there, those kinds of things to match what the needs of the individual homeowners are in those spaces. So we'll move off from there. I'll just say as we finish up, just make sure you're on the list, sign up for our quarterly newsletter so you stay in touch. I do want to give our thanks or remind you that there is a session coming November 10th on what the new NBC 936 energy tiers 3 and 4 look like. Angela will be on that call with Andy and Toby. So keep abreast of that one. On the left-hand side, you'll notice the regular series of construction heat and appliance installer validation refresher. November 3rd, Enbridge will be hosting that one. So still lots to come in the next few weeks. But let me take a quick second to thank first Enbridge for always for sponsoring and allowing us this opportunity. And then Angela, you're always kind to come on and help. I appreciate that. That's very nice of you and your experience as an energy advisor. I think you said it nicely. A good energy advisor's helping with this, right? They're helping builders stay out of trouble by looking for, we're going to call it rogue rooms from now on. But I think you'd agree, Angela, that that's a good role for energy advisors on this call to take.
Yep.
And Robert, my sincere thanks. Thanks for
always.
jumping in. That's so kind of you. And,
My pleasure.
If you were here, I'd buy you a Whopper at Burger King.
I know you would with a Coke.
So thank you again all for attending, and you will see, by all means, fill out the survey, please. And we'll see you again on a future webinar. Thank you.